Cement. A cement is a binder, a substance used for the constructions that sets, hardens, and adhere to other materials to bind them together. Cement is seldom used on its own, but rather to bind sand and gravel aggregate together. Cement mixed with fine aggregate products produces mortar for the masonry or with sand and gravel produce concrete. Concrete is most widely used material in existence and is mined only water and the planet's most consumed resource. Cements used in constructions are usually inorganic, often lime or calcium silicate based, which can be characterized as non-hydraulic or hydraulic respectively, depending on the ability of the cement to set in the presence of water. See hydraulic and non-hydraulic lime plasters. Non-hydraulic cements do not set in wet conditions or under water. Rather, it sets as it dries and reacts with carbon dioxide in the air. It is resistant to attack by chemicals after setting. Hydraulic is cements. Example: Portland cements set and become adhesive due to a chemical reaction between dry ingredients and water. The chemical reaction results in mineral hydrates that are not very water soluble, and so are quite durable in water and safe for chemical attack. This allows setting in wet conditions or underwater and further protects the hardened material from chemical attack. The chemical process for hydraulic cement was found by ancient Romans, who used volcanic ash pozzolana with added lime calcium oxide. The word cement can be traced back to the ancient Roman term opus cementium, used to describe masonry resembling modern concrete that was made from crushed rock with lime as binder. The volcanic ash and pulverized brick supplements that were added to the burnt lime to obtain hydraulic binder were later referred to as cementum, and cement. In modern time, organic polymers are sometimes used as cements in concrete. World production is about 4 billion tons per year, of which about half is made in China. If the cement industry were a country, it would be the third largest carbon dioxide emitter in the world with up to 2.8 billion tons, surpassed only by China and the United States. The initial calcination reactions in the production of cement is responsible for about 4% of global carbon dioxide emissions. The overall process is responsible for about 8% of global carbon dioxide emissions, as the cement kiln in which the reaction occurs is typically fired by coal or petroleum coal due to the luminous flame required to heat the kiln by radiant heat transfer. As a result, production of cement is a major contributor to climate change. Contents include chemistry, history, modern cements. Modern cements includes hyaluronic cement render, hyaluronic mortars, development of strong concretes. Property includes SiO2, Al2O3, Fe2O3, CaO, MgO, SO3. Portland cement blend. Expensive cements, wide blended cements, very finely ground cements, other cements, and so on. Setting, hardening, and curing. Safety issues. Cement in industry in the world.